I'm Sumit Sharma. I'm a third year PhD student at University of Alabama.
My name is Daniel Brady Valentin. I'm a second year PhD student here at the University of Alabama.
My name is Gabby Willis. I'm a PhD student at the University of Alabama.
So for this year design, we followed similar methodology as last year. We designed our beam according to conventional flexure mechanism, and we checked for shear as well. So we followed code provision from ACI, PCI, and ASTA handbook as well. And we developed a design program to carry out all those calculations. And we used software Response 1000 from University of Toronto in Canada to check our calculations as well.
Our mix design this year was very heavily favored towards early strength gain and high strength. We had a target compressive strength of 9 KSI, so we needed to add a lot to our mix in order to achieve that. So we had local aggregates that are standard for gate precast. We used an angular coarse aggregate and a sand as our fine aggregate. Mid-water, of course. Then we had a type 3 cement, Portland cement, for early strength gain, as well as silica fume to increase our compressive strength. After that, we had some admixtures in our mix. The silica fume decreases the workability of the mix, so we added some plasticizer and water reducer to make sure that, one, we could have a lower water cement ratio, get more strength, but also so that we'll still have good workability later on. We also had an accelerator, again, to make sure that we could get that early strength gain. So we got to see a lot of cool stuff at the site visit. This is the second year that we have gone to Gate Precast and taken a tour. And the tour was different this time than it was last year. We got to learn a little bit more about the technologies that they're using at Gate Precast. The precast industry is evolving, which is something that maybe we don't think about as much in regards to the construction industry and things like that. We learned that they're moving towards using CNC, a computer numerical control machine, to create their formworks. So that's going to be a lot more precise, and it will require less skilled labor. We also learned about a software called Concrete Vision, which is kind of a management software where they can, see what's being made, see for each individual piece if there's any quality control issues, and manage everything, manage their entire inventory as it's in the yard. So this allows them to work more efficiently and through each phase of the production process.
To test our beam, we used different methods to record the deflection of the beam. We applied the load using a jack, and to record the load, we use a 400 kV cell. And to record the deflection of the beam at different points, we use 5 string pods and several LEDs, which are a piece of instrumentation from the NDI optotrack system that records the variation of position of the LEDs in X, Y, and Z directions.
frame. Yeah, he slowly hangs on things inside.
So as I told you in design, we were expecting a flexural failure, but that didn't happen when we tested our beam. We got shear cracks a lot earlier than we expected, even though we provided enough stirrups and accounted for transfer length issues as well at the ends. But unfortunately, we got shear cracking at the near to the supports. After that, we experienced bonding failure with respect to our BD strand, because there were like huge cracks at the tensile flanks, which would induce higher bond stresses in the strands. And because our stirrups were open and they were not closed stirrups which confined all of the BD strands, so concrete at that region between the BD strands, which was subjected to high rated stresses, cracked, and eventually our BD elements were BD strands were delaminated. So this is what caused failure. Yeah, honestly, if this beam had behaved like exactly how you are supposed to behave, which might have happened in other occasions, right? We might not have learned about how detailing matters, or how simple things like your stirrup details, right? You are designing stirrup just for shear purposes, which we made, but we didn't design a closed stirrup which would have act to confine concrete as well. So basically, designing for flexor, we didn't take into account confined concrete strength, because we did not have to. But that had effects on other things, such as lamination of detachments. If concrete between detachments were confined, then they might have resisted bone stresses a lot further, and even just the right amount to give us a flexural failure. So these are the things, sometimes when we look at code provisions, we might just be looking them as a checklist, just to tick things off to meet every requirement, rather than understanding what the real behavior it's guarding after. So those are the things I'll be looking into more seriously for my future designs.
So from this competition this year, I learned once again that it's very important to take time to set up the instrumentation of the beam, because the more carefully we do that, the more accurate our readings are, and the easier it is to process the data later. And also taking notes and taking pictures for something, like I said, that helped us a lot, because if we hadn't done that, it would definitely take more time for us to correlate the data and what was going on with the beam. It was also a very important opportunity for me to go to Gate Precast and go to the plant and see how the formwork works and how they pour the beam and how the mix design is made there. Since my focus at the University of Alabama is mainly on research, that was a great opportunity to see a little bit of the industry out there.
Well, something that was very specific that I learned was really about how to analyze structural members inelastically. So we needed to find the actual deflection that our beam was going to fail at, and that required a lot of inelastic analysis. And that's something I didn't have a lot of experience with that I got to learn about. Another thing I learned is just how important it is to understand the behavior of your structural member rather than just following the code. We met the minimum requirements for shear and for cover on our beam. No more, no less, exactly the minimum. And despite having that minimum requirement, we still failed, or we still experienced shear cracks, and we still had the concrete fall off on the bottom flange. So I really understood how important detailing is and how important it is to understand exactly what's happening with your beam as far as the behavior is concerned.